So for this next video, we're gonna talk a little bit more about simple harmonic motion, and then we'll get to problem 34. Okay, so I'm just gonna start out by talking about simple harmonic motion in the context of this diagram. So let's just say we have a spring attached to a block, right? So however much this is compressed, this would be in this equation for period. In this equation, Hooke's law, for force of a spring, this would be the change in x, how much it's compressed or pulled past its equilibrium point. And its equilibrium point is where it's going to be at rest when it's not compressed or pulled. So now I just want to talk about another way to find the period. So another equation for period is 2 pi square root of length L over G. So length would just be talking about this right here, how much it's compressed or pulled out again. And then in something like this, to find the x position, like where it is at any certain time, you can use the equation x equals r cosine theta. So of course, and you can just plug in the time, and that'll give you where it is, because it's just going to be oscillating back and forth like this. Okay, so now we're going to look at question 34. What is the total distance traveled by the object during the first 2 seconds of its motion? And just a refresher, it's initially started by being pulled down 15 centimeters, okay? And then it's released. So, and the period is 2 seconds. So, so what we can do is we can look at it, by thinking, okay, so they ask how much total distance is traveled during the first 2 seconds of its motion. So we need to think about that in terms of period. So they told us the period is 2 seconds. So we need to think, how many periods is that? So all we have to do, 2 seconds, and they want to see first 2 seconds of motion, 2 seconds. So that's going to be equal to 1. So it's 1 period of 2 seconds. So next, all we have to do is think about the spring. Here we have the little diagram down here. So it's going to initially start at y, because this is y values. Y equals -15, and it's going to pass its equilibrium point at y equals 0 up to y equals +15, and that'll be after 1 second, and then it's going to just come right back down at 2 seconds and return to the position it was released at, because that's 1 period. So we can just look at that. 15 plus 15, 30, and then on the way back down, 15 plus 15, 30. So it's going to be 60 centimeters, because obviously it's just 1 period, so it goes up and then down, and the total distance it covers on the way up is 30 centimeters. Total distance on the way down, 30. So we just add those and we get 60 centimeters, right? And we look in our answer sheet and we say, oh, that's answer C, and that's our answer.